In this fictional experiment, we aim to investigate whether the distribution of tree type is independent of forest type. We record the number of each tree type observed in 2 different forest types and organize the data into contingency table. In Forest 1, we observed 45 oak trees, 70 pine trees, and 22 birch trees. In Forest 2, we observed 72 oak trees, 190 pine trees, and 72 birch trees. We calculate the total number of observations in each row and column using the Excel function sum. We also compute total sum of all observed frequencies. The expected frequency for each cell is calculated using the formula sum of frequencies for the chosen row multiplied by the sum of frequencies for the chosen column, and then divided by the total sum of all frequencies in the table. Then we calculate the squared difference between observed and expected frequencies divided by the expected frequency. The chi-square statistic is the sum of these values. The degree of freedom are calculated by multiplying the number of rows minus 1 by the number of columns minus 1. In our case, with 2 forest types and 3 tree types, we have 2 degrees of freedom. To assess whether the distribution of tree types is independent of forest type, we calculate the p-value corresponding to our chi-square statistic using the appropriate Excel function. If calculated p-value was greater than chosen significance level 0.05, we would fail to reject the null hypothesis. This result would suggest no significant evidence of dependence. However, our p-value is less than 0.05. Therefore, we reject the null hypothesis and conclude that tree type is dependent on forest type. Alternatively, we could compare our calculated chi-square statistic to the critical value from the chi-square distribution table at the chosen significance level. If the statistics exceed the critical value, we reject the null hypothesis. We can see that if we had chosen significance level 0.001 instead of 0.05, we would have failed to reject the null hypothesis.